Udan is Vidyarthi is already joined.
Sir is coming, sir. Just he called me.
Okay. Udan, please check with Vidyarthi have joined or not,
Okay, sir.
so that we can start on time. Good afternoon. May I know who has joined as ICSSR Project 24?
Yes, that is Vidyarthi Datta.
Oh, Vidyarthi.
Yes,
I mean, acha, it was
Campus
your
name.
project. Okay, okay. Acha. I was so you joined quite. Yeah, I think Udayan could not make it. So Udayan, Vidyarthi is already here.
Okay, sir. Okay, sir. We'll start.
Yeah, but I could not make it because it is written as ICSSR project. But from his photograph, I could make out it must be Vidyarthi. That's why I asked. Because I Vidyarthi is known to me for the last so many years. কেমন আছো?
হ্যাঁ ভালো আছি, আপনি ভালো আছেন?
হ্যাঁ স্যার, ভালো আছি. Good to
Okay,
see you. Good to see you.
yes sir, definitely.
Yeah, I missed you in IDSK event.
Oh yeah, no, in IDSK I was there. In one
Yeah,
session I had one class also there.
yeah, I know because I went there with PSM, and by
Okay,
the time your session was over.
yeah, that's, yeah.
Yeah,
That's true.
Hmm. Who is writing this Bechara? Sushmita J. Who is she? Who is she? Udan, can we start?
Yes, sir. Yes, sir. We'll start. Good afternoon, everyone. A very warm, enthusiastic welcome to all the participants joining us today from across the institutions and regions. Hi, everyone. I am your session moderator, Udayan Ghosh, Assistant Librarian at Ashoka University. We are delighted to have with you as the fourth day of exciting and future-focused webinar series on behalf of HDFC Library and Ashoka University. It gives me immense pleasure to welcome you season 1 of Library Colloquium. We are proudly present this webinar series designed to strengthen the librarians evolving the role of strategic partner in teaching, learning, research, and innovation and knowledge management. This series explores five critical domains shaping modern librarianship: artificial intelligence in libraries, research metrics in evolution, scholarly communication, research mapping, and standardizing usage metrics in libraries. The word librarian has been thoughtfully divided into nine meaningful opulence, each representing the evolving roles, strength, and professional excellence of modern librarians. These nine pillars reflect how librarians contribute as leader, innovators, and facilitator and guardian of the knowledge in today's academic and research ecosystem. So today's webinar covers a highly vital and relevant topic in the current academic and research scenario. As the research output continues to grow our globally and measuring scholarly impact responsibly has become more important than ever. The institutions, researcher and funding bodies and librarians increasingly rely on the metrics to understand quality, visibility, reach, and engagement. Today's discussion is based on the thought-provoking title Navigating Multidimensional Research Metrics from Impact Factor to All Metric Indicators. So this season will be help us to understand the transition from traditional citation-based indicator to newer alternative metrics that capture online attention, policy influence, and broader societal impact. It is time to welcome our esteemed dignitaries to today's session, Dr. Vidyarthi Datta Sir, Associate Professor and Department of Library Information Science, Vidyasagar University. Dr. Vidyarthi Datta Sir is a respected academician and researcher known for his contribution to library and information science, currently communication, bibliometric, and research evolution. We are truly honored to have you, sir, with us. Now I welcome our distinguished speakers, Dr. Santanu Ganguly, Director of HDFC Library, Ashoka University. Dr. Ganguly's visionary leadership, commitment to academic excellence continue to inspire innovation, learning, and professional growth within a library community. Sir, we are sincerely welcome you. Thank you for the constant support. Without taking much time, now I request Dr. Vidyarthi Datta sir to kindly deliver today's keynote session. Sir, we are eager to learn from your valuable insight. Over to you, sir.
Thank you so much. Thank you so much. Very good afternoon to all of you, this August gathering. And thank you so much, Dr. Shantanu Ganguly, And not only Dr. Shantanu Ganguly, but my beloved Shantanu Da also, as I usually address you. And thank you, Udayan, my dear student. He is my dear student, Mr. Udayan Ghosh. And so let me start. Let me first share my screen. So am I audible?
Yes, sir. Perfectly, sir.
Okay. I want to share my screen. So is it visible, my screen?
Yes, sir. Yes, sir. It's visible.
Visible. Okay, okay. Now, is it okay now? Full screened?
Yes, sir.
Okay. So very good afternoon. And thank you very much, the authority of the esteemed Ashoka University, the HDFC Library of Ashoka University. Thank you, Shantanuda, for giving me opportunity to share my views with you, with your platform. So let me start. So the title of my topic is Navigating Multidimensional Research Metrics from Impact Factor to Altmetric Indicators. Actually, I will just cover the entire spectrum of research metrics. Now, research. Today, we are very keen with this term. So, research. So, it is not search. Search is already done. It is repeated search. That is research. And the main intention is to unlock with a key. Now, the biggest question of today's research is quality. This is the crux point. Whether quality is maintained is research. Actually, concept of metrics arrived due to that very reason, whether quality is maintained. But this was not the case in earlier, particularly before 1960s, 50s or 60s. Then it was obvious that yes, research means it will have quality. But today, question arises: the research is the research has enough quality and it is of enough standard, sufficient standard. So that is the change. Now, metrics. What is metrics? We all know it is a measurement or quantitative assessment commonly used for assessing, comparing, and tracking a performance or production. And metrics are always represented by some numbers, numerical values, which may be cardinal or may be ordinal. Now, Charles Babbage, we all know him, father of the concept. Actually, Charles Babbage is known as the father of computer, but Charles Babbage is also the father of concept of metrics. The question is how to quantify the quality. Can I quantify the quality? And Charles Babbage advocated for the quantification of scientific articles or papers by proposing that the number of papers authored by a scientist could be used as a measure of their productivity or quantity and metric. And this idea introduced the concept of quantification of quality in a more systematic and objective way. And at that time, scientific contributions were often judged by more subjective proofs of genius or book publications. Now, later, John Derek Disola Price, he is known as the father of theoretical bibliometrics and scientometrics, and he was a physicist and historian of science. And he actually measured the growth of literature, and he estimated the number of the scholarly periodical titles being published by the end of 20th century would exceed 1 million, and he declared it at the end of 1950s. That was so interesting. And he laid the foundation work for the quantitative study of science using data to analyze how science grows, evolves, and functions as a system. And his seminal book, Little Science, Big Science, and Beyond, it was one of the domain book in the entire history of science. And it was first published in 1963, and it scientifically analyzed the exponential growth of modern science and the resulting shift in its organization and funding. Now, Little Science, let me just explain. The very title of the book was Little Science and Big Science. And what are those? Little means small, big means very large. So, what is the implication? Actually, Disola Price, by the term little science, he meant research under passion. So little science, science with little research team, little group, and big science means science with very huge team. But nowadays, little science becomes equivalent with research under passion, and big science becomes equivalent with publish or perish pressure. Actually, today's research communities are continuously haunted by this continuous chasing of publish or perish pressure, and which eventually figures out that no, it is not research is no longer under passion, but research under compulsion. I have to do that. I must do that. That is the point. So this is the difference between. And one interesting comment was once made by Professor C.N.R. Rao. I heard it one of his lecture in my university, Vidyasagar University, once he visited around a decade back. And he said, yes, Professor C.N.R. Rao said, yes, big science means bomb science. And actually, the big science, Professor Rao equated big science with bomb science because the landmark between little science and big science was marked by Second World War. And particularly, yes,
Please
yes,
continue, sir. Please continue, sir.
okay. And particularly, Second World War spanned from 1939 to 1945. But during last 3 years was very important when in 1945 nuclear bombing occurred in Hiroshima and Nagasaki, we all know. And therefore, Professor C.N.R. Rao often used this as metaphor, yes, big science with bomb science. That is the point. Now, glimpses from Little Science. I just want to present what was Little Science by some sets of picture. We all know. We all know. And Lord Rutherford, Ernest Rutherford, who discovered proton. He did his experiment, and this apparatus design was made by himself. Also, J.C. Bose developed his own experimental setup. These were individual research and very small group research, and they were not very rich men, rather very middle, they belong to very middle earning group. And J.C. Bose's apparatus, it was very cheap. This component of this apparatus was very cheap. So one thing. And another very interesting example of little science, these are world's two smallest equations expressed to most largest and deepest concepts. One was E is equal to h nu and another is E is equal to mc square, where nu is the frequency and h is Planck's constant. And here m is mass and c is the speed of light, or broadly speaking, speed of electromagnetic radiation in free space. So these two equations were discovered without any high-priced or highly costly laboratory setup. So Max Planck and Albert Einstein. So the laboratories were essentially their brain. These were the period of little science. Another important, our uh, Acharya Satyendranath Bose, Vigyan Acharya S.N. Bose, and Professor Gyan Chandra Ghosh or J.C. Ghosh. He was the founder of Indian Institute of Technology, Kharagpur, IIT Kharagpur. So S.N. Bose and J.C. Ghosh, and both of them were narrowly missed Nobel Prize. But till date, around 7 scientists were Nobel laureate who used the theory of S.N. Bose, theory of boson particle. So these were the period of little science. This is one cartoon, the big science and the little science, the laboratory setup and big science. Only paper, paper and paper, deluge of publications. And this is the evolution of academia. This is just a cartoon, these are. Earlier it was published, then publish or perish, then publish in high impact journals or perish, and eventually published frequently in high impact journal, and maybe you won't perish. So that is the point. So this is publisher perish pressure, and these are some sets. So today the essential tools of researchers are here, only three are shown: Scopus, Web of Science, and Dimensions. But today PubMed is there, OpenAlex is there, Lens is there, Crossref is there. Particularly PubMed and OpenAlex, they are far more active today. Even OpenAlex will soon become exceed even Dimension, may exceed. But Dimension has one unique thing. Dimension consists of both citation data and altmetric attention scope data. That is the thing. So earlier, Web of Science was the only source. Later, Scopus outnumbered Web of Science, and today Dimension outnumbered Scopus. So in this way, the databases are continuously deluging and deluging and deluging. So, father of theoretical bibliometrics, we already mentioned John Derek de Sola Price, and Eugene Garfield. He is known as the father of applied biblioscientometrics. Actually, he was the father of citation index, and he was the founder of Institute for Science Information at Philadelphia in 1964 in USA. And he initiated Professor Eugene Garfield initiated a new type of indexing, that is citation indexing, and he developed a tool, Science Citation Index, in 1964, followed by Social Science Citation Index, introduced in 1973, and Arts and Humanities Citation Index, which was started in 1978. And all these tools are merged into a web of knowledge today. And earlier, up to the year 2005, these tools were published by Institute for Science Information or ISI of Eugene Garfield. But since 2005, these uh, tools were started publishing by Thomson Reuters, and since 2017, Clarivate Analytics took charge to publish these tools. So now Web of Science is published by Clarivate Analytics. So we have already came across father of theoretical scientometrics or bibliometrics, then father of applied scientometrics and bibliometrics. Now Samuel C. Bradford, who is known as father of empirical bibliometrics or scientometrics, father of empirical biblio or scientometrics. And he was the Science Museum librarian in Britain. He studies journals as sources, and he worked on geoscience, and he found out the core journals. And Bradford showed that what journals produce, how many articles in a subject and how they are distributed, or how are the articles in a subject are scattered across journals. And in this way, he developed a method for identification of the most productive journal in a subject. And what he called documentary chaos, actually, by applying Bradford's method, it is possible to measure scattering of documents or scattering of articles over journals or documentary chaos. So next, Alfred J. Lotka, he is also known as father of empirical biblioscientometrics. Bradford found out the relationship between number of articles and number of journals, whereas Lotka found out the relationship between number of authors and number of journals. And this is the generalized form of Lotka's law, Fn equal to C by n to the alpha, where n is Fn number of authors publishing n number of articles. This is actually generalized form of both Lotka's law and Ziff law, and Ziff works on distribution of words within a text. Now, when we have to find out any research impact metrics, it is a statistical analysis of bibliometric data actually, and the basic parameters we have to consider are it may be country or any university or institute, or the study may be executed over author or journal or within a subject domain. And bibliometrics therefore measures the amount of scientific and research activity in a subject category or journal, country, or any topic of other area of interest. Now, citation-based indicator. Now, on the basis of chronology or time scale, here we have divided the research metrics or research quality indicators in three categories. One is classical indicator, another is neoclassical indicator, another is modern indicator. Now, the classical citation-based indicator, which are based on mainly simple average model. So these are the main classical indicators. Number one, citation count. This is very basic indicator. Then impact factor, then immediacy index, then half-life measures, half-life which measures obsolescence, next self-citation, then cited uncited ratio, and also cited citing or cited source ratio. Now impact factor, it is developed on simple average model. Simple average model means just plain average or arithmetic mean, nothing else. Impact factor may be of 5 types. Impact factor, a 2-year impact factor and 5-year impact factor are there. Normalized impact factor, aggregate impact factor, and wave impact factor. Now, this is the basic formula for impact factor. We all know it. So, I'll not go into much details. Where in the numerator, number of citation comes, and in the denominator, number of publications come. So this is just the ratio between total number of citation to total number of publication. Very simple thing, simple arithmetic mean, where citations are counted for up to previous 2 years publications, and publications are corresponding to the previous 2 years. So, but citations are during present year, but for the previous 2 years publications. So this is the basic formula for impact factor, and the impact factor is historically significant because it was the first and foremost research metric or research quality indicator. Actually, it indicated the quality of a journal. Earlier, it was used as journal quality indicator. Later, also, it was started to be used for author or other parameters. Next is immediacy. Next is normalized impact factor. A normalized impact factor, it was introduced by Dr. B.K. Sen in 1992. Actually, impact factor we just mentioned, it is based on number of citations. In the numerator, you see the number of citations are there, C1 plus C2, and in the denominator, number of publications are there. So therefore, in the numerator, number of citations are there, and therefore, impact factor is a highly subject-dependent parameter because it depends on particular subject. And citation accumulation is a function of the nature of subject. All subjects are not at all equally citation active. For instance, humanities or social science, they are very less citation active and very little number of citations are accumulated for those subjects. And today, most or highest citation active subjects are medical science along with some areas of biological science. For instance, proteomics, protein chemistry, genetics, and microbiology. These are highest citation active area today. And therefore, it is often found that in medical science or in microbiology or genetics, we will frequently find high impact factor journal like 40 or 50. Even Nature biological science journals, they have impact factor more than 50 or 60. And many, the mediocre journals of microbiology and medical sciences are around 15 or 20. But on the other hand, in social science, the highest quality journal has impact factor is around 3.5 or 4. 3.5, 3 or 3.5. So very less citation active area. In physical science also, that is not very much citation active like bioscience. Therefore, citation accumulation varies subject to subject. So to standardize impact factor within all subjects, Dr. B.K. Sen introduced the normalized impact factor, which is equal to impact factor into M, where M is a multiplier, and M is equal to 10 by HIF, where HIF is the highest impact factor of the particular journal under specific category in a particular year. Therefore, NIF is equal to 10 into impact factor divided by highest impact factor. So he suggested multiply impact factor by 10 and divide it by the highest impact factor of the impact factor value of the journal in the concerned subject area. And in this way, the impact factor was somehow amicable and balanced among different subjects. That is the point. Next, immediacy index. Now, immediacy index actually it sees the instant effect. Immediacy index is equal to C by X, that is number of citations divided by number of publications in the particular year. Impact factor is for previous 2 years, but immediacy index is for the same year. Say I want to see the immediacy index of a journal for the year 2026. Now the journal is continuing to be published. It's still publishing. Only few issues already published and more issues to be published. I want to see up to the month of April of 2026 what is the immediacy index or instant effect of the journal. Then I will see how many articles have been published by this journal till date and how many citations they acquired. they received, and divide number of citations by number of papers. And so now one thing is citation is a function of time. Therefore, it takes time to accumulate citation for a journal or for an author. Therefore, immediacy index, it measures, it is like impact factor, citation by number of citation divided by number of papers, but within the same year. Next, half-life, it is of two types, cited half-life and citing half-life. Now, half-life actually measures obsolescence, and here it is given. Suppose we want to find out the half-life of any say any journal which in the year 2019 say. Now we have to calculate the number of citations received by that journal starting from the year 2019, and then here total number of citations is 4016, and then we have to find out the percentage of number of citations corresponding to each year to calculate the cumulative citation. And in the cumulative citation, we have to see the 50% when the total number of citations, 50% figure occurs. Here 50% figure occurs between 2013 to 14. Therefore, starting from 19, here cited half-life is 6.5 years. So this is the cited half-life. It actually measures obsolescence. Obsolescence means outmoded or outdated. Therefore, half-life measure how quickly a particular journal or a particular author becomes outdated or outmoded. Next, self-citation. Self-citation means when one particular journal cites its own paper or one author cites his other papers. It may occur for institution also. So there are three kinds of self-citation: journal self-citation, author self-citation, and institutional self-citation. Then site score. This is site score. And site score metrics are part of the Scopus basket of journal metrics that includes SNIP, means source normalized impact per paper, SJR, SciMago journal rank, citation and document counts, and percentage cited. The integration of these metrics into Scopus provides insight into the citation impact of more than 22,000 journals. So this is the site score calculation. This is also based on simple average model, and this is the ratio between number of citations to number of publications. And site score metrics calculate the citations from all documents in year 1 to all documents published in the prior 3 years for a title. So site score. Therefore, let us chalk out the brief history. Now, classical indicators are based on simple average model or arithmetic mean model. And post-2K or modern indicators, post-2K means after the year of 2000. That's why it says post-2K. So post-2K and modern indicators, that is H and H type indicators, are based on relative distribution model. Here are the basic difference. The classical indicators all are based on simple average model, whereas modern indicators are based on relative distribution model. And the classical indicators are mainly journal level indicator, and the concept of author level indicators and article level indicators were developed after the year 2000. The introduction of H-index by Hirsch in 2005 was the milestone of modern or post-2K metrics, and the introduction of the concept of altmetrics by Jason Priem in 2010 was another milestone, particularly in the developing alternative metrics for author or article or journal. And at this point, let us chalk out the skew pattern of citation. And here we'll highlight why simple average model is not perfect, rather is a faulty method to develop any indicator. Why? That is due to the skewed pattern of citation. What is skewed pattern? Skewed pattern means biased pattern. Biased distribution of citation over the articles. Now, in the UNESCO Science Report towards 2030, Soet et al. Remarked that around 78 lakhs individuals globally today may be formally distinguished as scientists, but still the different scientometric measurements of productivity and citation studies appear highly skewed to a very small number of groups. And this is the paper mountain. This is just, it is the part of a paper which was published in Nature few years back. And the title of the paper was Top 100 Papers, World's Top 100 Papers. This was the title of the paper. And it showed that if the first page of every item indexed in Web of Science are collected and stacked one after another, then eventually it will attain the height of nearly 6,000 meter. 6,000 meter means height of Mount Kilimanjaro. You see, this is the height. This is 6,000 meter height of Mount Kilimanjaro, whereas this is the 300 meter height of Eiffel Tower, and this is 830 meter height of Burj Khalifa. Burj Khalifa's height is 830 meter, and the height of Mount Kilimanjaro is around 6,000 meter. So if you take printout of only the first page of all items indexed in Web of Science, then it will touch, eventually almost touch the height of Mount Kilimanjaro. Now, out of so many papers, and the number of papers figured around, that was more than 5 to 6 crores. And of these papers, the total height is 6,000 meter. Up to 2,500 meter, this much of paper received no citation, and this much of paper received only 1 to 9 citation, whereas this much of paper received 10 to 99 citations, and only topmost few millimeter height, and this much of paper received more than 100 citations. And the number of papers here it is given around 10 lakh. So out of several crores, nearly 5-6 crores, only 10 lakh papers receive more than 99 citations. That is from 100 to 999 citations, still less than 1,000. Okay. And majority paper received 1 to 99 citations. This plus that. So this is the paper mountain. And here I will highlight top ever cited paper in history. This is the world's most cited paper till date. Protein measurement with the Folin phenol reagent. Authored by Oliver Lowry and published in 1951. This paper received more than 3 lakh citations till date. And these are second, third, fourth, and fifth top ever cited article. Now, previous paper received more than 3 lakh citations. The second paper received around 2 lakh 13,000 citations. You just notice the fall of citations, such a huge fall. 3 lakh 5,000 to 2 lakh 13,000. Next paper received 1 lakh 55,000 citation, followed by 65,000 citation and 60,000 citations. So this is the thing. So high citation is very rare, high or large number of citations. And in the domain of large number of citations, citation fall also occurs very fast or very quickly.
Sir, can you
It's a
explain
very,
previous slide? High citations paper, please.
pardon? Yes, you repeat, please. Your
Yeah, can you
question.
please explain a high citation paper, sir? In which field it has got and all?
This is the world's top most cited paper as Nature Journal expressed. Okay, this is the title of the paper, and this is the second top cited paper. This is third, fourth, and fifth top cited papers. These are okay. So, what do you want to know? Please repeat. High cited paper means the papers which receive large number of citations.
Vidyarthi, you please continue with your presentation. We will take up the questions at the end. Participants are requested not to pose any questions right now. Just keep it stored in the chat box. We will take it up one by one after the session is over. Please don't disrupt the speaker.
Okay. So, what I want to say that citation fall is very huge. And the consequence of citation fall is that only 3 articles all time received more than 1 lakh citations till date, and only 3 articles received number of citations between 50,000 and 1 lakh till date. And it is thus interesting to note that more than 50,000 citations are received all time by only 6 articles. And it was observed that at least 12,119 citations are required to rank in the top 100 list. And here the top citation subject domains. And I already mentioned that all subject domains are not equally citation active, and many of the world's most famous papers, including Einstein's special theory of relativity, the determination of DNA double helix, and the discovery of high temperature superconductors, did not make it to the top 100 list. And it is also found that the top 100 list has been dominated by protein biochemistry publications that include papers on protein quantification assays, protein characterization, 2D gel electrophoresis, crystallography, and protein chromatography. So, protein chemistry, protein science, or protein chemistry is the world's topmost citation active domain today. And protein science is related with the broad subjects like mainly genetics, microbiology, and biochemistry. So these areas are most citation active area today. And only 12% of articles are not cited. Only 12% of medical articles are not cited compared to about 82% of the humanities. That is the point. So in medical science, only 12% articles remain uncited, whereas in humanities, 82% articles remains uncited. And it's 27% for natural science and 32% for social science. that is the percentage of uncitedness, and for everything except humanities, those numbers are far from 90%, but they are still high. One third of social science articles go uncited. Now, neoclassical citation-based indicators. There are some neoclassical citation-based indicators like eigenfactor score, article influencing score, and source normalized impact per paper. These are actually used by Web of Science. This is the eigenfactor.org. This is the site. And this is the method of calculation of eigenfactor score. This is citation matrix is there and column matrix are there. And article influencing score is nothing but just 0.01 multiplied by eigenfactor score. And therefore, AI is always less than 1. AI greater than 1 means this belongs to more than average level. And this is the screenshot of the page eigenfactor.org. Now, let us now come to the point of modern citation-based indicator. So we have already pointed out classical citation-based indicator and neoclassical citation-based indicator. Now modern citation-based indicator. So the basic and simplest modern citation-based indicator is IN index. And for n equal to 10, it becomes I10 index. We all know. It was actually introduced by Google Scholar. Then SJR indicator. It was introduced by Scopus. H index. This is another path breaker. H index was introduced by the physicist Hertz in the year of 2005. And the discovery of H index just unveiled a new arena in the history of scientometrics and informatics, because H index was the indicator which was not based on simple average model but on relative distribution model, followed by a G index and H type index and other indexes based on H index and number of publications, indexes for personal success of researchers, indexes for characterization of research networks, and indexes for measuring quality of scientific output. And these are the non-citation indicators. There are so many non-citation indicators also. For instance, co-authorship index, degree of collaboration. This is based on co-authorship index only number of authors, degree of collaboration, number of authors from different institutes, activity index, attractivity index, relative growth rate, doubling time, specialization index, research priority index, participative index, productivity index, equivalent index, and Salton index. But all these indicators are not based on citation. So these are known as non-citation indicators. Now H index, actually today H index, when it was introduced in the year 2005, then initially it was an individual indicator, but today H index is no longer an individual indicator, but H index indicates a cluster of indicators or groups of indicators. And there are so many indicators which are developed on the basis of H index. So H index actually basically a method. So it opened and it unveiled a new horizon. That is the point. Now, H index has so many types. Time normalized H index is there. H index divided by age of the particular publication. Publication normalized H index is also there. H index divided by number of papers. Tapered H index is there. H index within a particular zone, and temporally bound H index or H dependent H index. Now, fundamental H-derived or H-type indices, there are some indicators which are derived from H-index, directly derived from H-index. For instance, E-index, it defined as square root of total citation minus H-core citation, and it is also known as complementary H-index. R-index, which is square root of total citation, A-index, total citation by H, ratio of total citation to H-index, G-index, G square less than equal to total citation, W-index, W citations received by top 10 W papers, and HG-index, this is the geometric mean of H and G indices, and M-index or median index. These are fundamental H-type indices, and this is the graph which clearly defines H-index. So if we graphically plot the ranked publications and the corresponding citations, number of citations, then we get this type of graph, which is a rectangular hyperbolic graph. And this is the square area. This area is called H square zone. This is H-axis zone, and this is tail zone. The citation within this region, that is equal to H square, from where H-index is derived. That means when top ranked H publications received at least H citations, then that will be the H-index. Here, area under the curve indicates total number of citations, and area of this square only indicates the H-core citations. So the square root of this area of the square, that is the length of one side of the square equivalent to H-index. And this is excess citation, this plus that. This is known as H-excess citation, and this is H-tail or tail citation. So excess citation plus tail citation, the summation is equal to net excess citation, and square root of net excess citation is E-index. And square root of total citation, that is the area under the curve, equal to R-index. And the ratio of total citation to H-index is equal to A-index. So these are the four fundamental indicators. And this is the same. This is H-tail curve, tail citation. And this is upper H-core or H-excess zone. This is lower H-core or H-tail zone. So this is the distribution of H-index. So from here, it is clear that H-index is not a self-sufficient indicator, but H-index is a lame indicator. Why? Because H-index does not incorporate total citation. Because total citation is indicated by the area under this entire curve. But H-index indicates it is based on the area of the square only. So H-index ignores this citation, this much citation, that is H-excess citation plus this much citation, that is H-tail citation. Now H-index can be complete only when jointly expressed with E-index, because E-index incorporates this much citation plus that much citation. Therefore, when we tell H-index together with E-index, then only H-index can be complete. Therefore, E-index is known as complementary H-index. So H-index is the lame indicator if used alone, and it can be completed with its two crutches. One is E-index derived from net excess citation, and T-index derived from tail citation. Actually, tail citation is not yet used, but few psychometricians argued that yes, actually, after hers, some cytometricians, they defined index as square root of this citation plus these citations, but some cytometricians, they argued that no, Square root of this should only be E index, and square root of this should be T index or tail index, another index, because it indicates tail citation. Actually, what occurs in this tail zone, large number of papers receive very few number of citations each, whereas in H-access zones, few number of papers receive very large number of citations each. So just complement. This upper zone is just contrast or complement to this tail zone. That is the point. And therefore, H index alone is the lame indicator. And this is the EH plane or EH balance indicator. This is also very important indicator. If we divide the relative value of H index and E index for a set of authors, we'll come across these four zones: high H, high E paper, author or journal, high H, high H, high E, high H index, high E index, author or journal, low H, high E, low H, low E, and high H, low E. And it is found higher H index means high citation loss and H index will be unreliable. Sorry, higher E index. So higher E index indicates unreliable H index. That means high citation loss, and lower E index indicate low citation loss and H index will become reliable. And this is the ISO H index line where H index is identical but E index varies. E index for a particular different E indices for a particular H index, and this is ISO E index line, different H indices for a particular E index. So identification of H index, and E index for any particular identification of H index for a particular E index and identification of E index for a particular H index. That is the point. And these are very important because the ISO H index line for a particular author or journal or ISO index line, calculation of ISO H index or ISO index line will eventually portray the balance between H course citations and excess citations. So the larger the E, the larger the net excess citations and higher the loss of citation, and the smaller the E, the more reliable the H index. So study of EH plane is an important study. Now, is H index at all reliable? There are some demerits of H index. Here it is an imaginary conversation. There are two scientists, Stephen Hawking and Edward Witten. And according to 2 years back data, Stephen Hawking had H index of 121, whereas Edward Witten had H index of 192. Now, we all know who is Stephen Hawking. Everybody knows. Very renowned physicist. But few people knows and people hardly knows about Edward Witten. He was also another physicist. Even all physics people may not heard his name. So their imaginary conversation, Edward Witten says Stephen Hawking, my H index is bigger than yours. But Stephen Hawking replies, but more people know who I am. And this actually indicates, say yes, H index is not at all the measure of popularity. H index does not indicate the measure of popularity. That should be remembered. Now, why H index is debated, there are so many reasons. Number one is variation in types of publications, then author name disambiguation, then publisher Paris pressure. Author name disambiguation is a very big problem. For instance, in Web of Science, I found 7 different variations of Professor B.K. Sen's name. B.K. Sen, Sen B.K., Bimal Kanti Sen, Bimal Sen, Sen Bimal Kanti, like that. So that is a big problem. Standardization of author name. Publisher Paris pressure, disciplinary difference due to difference in citation threshold for different research domains, manipulable through self-citation, recitation, coercive citation, etc. These are direct factors. Based on only Google Scholar output, ignores documents not indexed by Google Scholar, varies over databases, that is Scopus, Web of Science, Indian Citation Index, Google Scholar, like that. And the H index is an integer that minimizes its discriminatory power. Ruan and Toll proposed a rational H index that interpolates between H and H plus 1. Now, here are a few contemporary mathematicians who solved major open problems and have relatively low H index, computed using citation data math science net. For their stature in the mathematical community. For instance, Y. Zhang, he proved boundedness of gaps in primes, but his H index is only 2. G. Perelman, he solved Poincare conjecture, very basic problem in mathematics. His H index was only 10. And Andrew Wiles, he proved Fermat's last theorem, but his H index was only 15. And it also signals that mathematics is also comparatively low citation active subject domain compared to protein or biological or medical sciences. And let's examine the case of Einstein, who has 147 articles listed in the Web of Science database between 1901 to 1955, the year of his death. And for his 147 articles, Einstein has received only 1,564 citations during his lifetime. That is very low number of citations. Now, if we add the citations made to his articles after his death, Einstein has received a total of 28,404 citations between 1901 and 2019, which earns him an H index of only 56. Yes, H index 56 is very big, but it seems smaller compared to the person like Einstein. So only 1564 citations over 147 articles at the time of his death. And the H index of 56 might seem large, but there's been about 70 years of citations after his death. So even when he was 76 years old, he would have had an H index that might be considered mediocre for someone at that age, and someone considered to be one of the most prolific academics of all time. So Einstein had such a poor H index. Now, other indicators, other indexes based on the H index and number of publications like Q index, QIP index, P index, PI index, PIX, perfectionism index, and extreme perfectionism index, EPIX. And indexes, these are indexes for measuring quality of scientific output. Annual impact index, MAPR index, T index, RPG index, TPP index, and TIA index. And now, let us represent daily index, the unification model will present another indicator. Actually, all these indicators I just stated, they look after on a particular parameter, but create biasness at some other point. And another indicator, that is del HIPSA index. This is delta and this is epsilon, del HIPSA index, and that is the unification model. Now in this method, this is actually a new method of deriving indicator, deriving so far possible least biased indicator. This is the ratio method, and here the ratio of total citation to net excess citation is taken, where total citation is r square divided by e square, and it becomes as r square by r square minus h square, because e square means equal to r square minus h square, and is equal to 1 minus h by r whole square, where h is h index and r is r index, and delta is actually the ratio of h index and r index, h by r. Delta is equal to h by r square, 1 minus del by minus 1, or 1 by 1 minus del. This is actually equation 1, and misprinted it is 10. Now 1 minus del to the minus 1, this is, if we expand, it will be like that. 1 plus delta square plus delta cube. This is Taylor expansion. For delta is equal to h by r whole square. This is actually Taylor expansion. Now here delta cannot be equal to 1.
So sorry
but
for interrupt. We have to quickly wrap up. So then we have Q&A session. Then Dr. Santu Ganguly also have presentation.
Okay. So when I have to end? How more time? Hello,
Sir,
yes.
yes, 5 minutes, sir. 5 to 8 minutes.
Okay. So just I quickly point out. So actually, by this method, by total citation to net excess citation ratio, we eventually found out this. The ratio of total citation to net excess citation may be expressed like this infinite convergent series: 1 plus h core citation by total citation plus this square plus cube, etc. And eventually we expressed it like this, and this is equation 7. This is the Riemann zeta function. So daily index is expressed in terms of Riemann zeta function, and there we found several values. This is xi1, zeta 1, and its value ranges from 2 to 7, zeta 2, zeta 3, zeta 4, like that, and they all gradually tend to 1. And these values here, let me explain it. The xi2 explains, xi2 is of the order of 1.62. It means H core citation amounts approximately 60% of the total citation. Similarly, xi3 indicates H core citation amounts approximately 20% of the total citation, and xi4 indicates it will be around 8 or 4% of the total citation, like that. So higher order Riemann zeta function thus indicates gradually lower magnitude of H core citation, and this is the reason the higher order zeta functions do not stand logically, as H core square cannot vanish totally as all. And size of H core zone or H core square gradually diminishes for the converging nature of Riemann zeta function, and daily index is thus a determining factor. So next, altmetric indicators, and there are several altmetric indicators we know. This is altmetric manifesto, but altmetrics has a limitation that without DOI it cannot function, and this is the donut we all know. And there are some interesting altmetric tools, of which some are inactive today. For instance, impact story. This is very active tool. Reader meter was active, it is now inactive. Science card is also inactive. PLOS Impact Explorer. This is the PLOS Impact Explorer and Paper Critic. These are important tools. And Crowdometer also, once upon a time, it was very interesting tool, but now it is inactive. And from these sites, the altmetric attention score can be calculated. And one important point is citation count versus altmetric attention score count. They are hardly in consonance. And high citation papers, usually they have low altmetric attention score, whereas high Altmetric attention score papers usually receive low citation. So both high citation and high Altmetric attention score is a very seldom combination. And most common is low citation plus low Altmetric attention score. So it is also another important area of study. And these much types of indicators exist today. Just to see, this is like a periodic table of chemistry. Citation, number of citation, number of publication, number of links. These are basic indicators. Then webometric, these are webometric indicators. These sites, these are bibliometric indicators. These are webometric indicators. These green sites, these are altmetric indicators. And all these indicators are blue indicators. These are H-index based indicators. So this is the number of indicators. So many indicators exist today. So that is the point. So let me end here because there is no time. So thank you so much.
Thank you very much, sir, for such an enlightenment and thought-provoking presentation. We will now move forward to the question answer session. Participants are requested to kindly post their question in the chat box or raise their hand. We'll take a selected question as time permits. And also, we have a special announcement. I am pleased to share that our next session is scheduled tomorrow for 2:30 onwards as countermetrics trusted users data resource person Ms. Tasha Melins, Executive Director, Countermetrics with Mr. Kenneth, Library Ambassador, Sellers. And also we have our flagship webinar will be held on 27th April on AI in Library Operation, featuring Dr. Sukhdev Sim, former Deputy Director General, NIC, along with speaker Dr. Shantanu Ganguly.
Then there are a couple of questions are there on the chat box. Probably if you can read out and moderate one by one, so
Okay.
Vidyarthida
Yes.
can reply to them.
Yes. So first question we have, how citation indexing can be used in school or university library or government? Can you have demonstration?
School or university library.
Yes.
Okay. No, citation indexing actually it is today what is used. It is usually based on some databases. For instance, you can use Scopus or you can use OpenAlex or PubMed like that. And if in your school or if in your university you have access to those databases, then yes, you can use. If you want to use the citation indexing of any author in your school or from your university, that can be easily done. But the articles which are not indexed in Scopus or Web of Science or for published in unindexed journal, articles published in unindexed journal and also cited by unindexed journal, those are very difficult to find out the data, citation data. So there are many huge volume of dark citation data are there, which are not yet indexed, which are beyond record. And for that, the all unindexed journal should be indexed. And with that purpose, once Indian citation index was started, but that is not functioning well now. So that is the thing.
Okay. So our next question is, as a research scholar, which indicator has to follow for journal publication?
Yes, please repeat question.
One question is, as a research scholar, which indicator has to follow for journal publication?
Which indicator has to follow for journal publication?
Yes, sir.
Okay. So for journal publication, you have to see it is covered or it is indexed in which database, whether Web of Science or Scopus or OpenLX, and then we have to see the reputation of the journal. How old is the journal? What is the subject domain is the journal? The editorial board, or whether it publishes regularly. So many parameters should be checked for publication. Okay, so that is the point.
Okay. So next question is, what kind of metrics required for LIS professional to elevate their career?
What kind of metrics?
Research
Actually,
metrics
question.
required. Yes, what kind of research metrics required for LIS professionals to elevate their career?
Actually, I also don't know the answer of this question. To elevate the career, the LIS professionals should rely not any particular indicator, but a series of that I said during last 1 hour, few minutes, that we should not rely on any single point metrics. And there should be standardization of all metrics, because no single metric can evaluate any article or any author or any journal in a perfect way. No indicator is complete. So standardization of indicators, number of indicators, that's why I have told the Del Epsilon index. Yes, that is one mode of standardization. So we have to do standardization, and there is a scope of huge research in this area. And we LIS professionals should do research in that area. How to standardize indicators? What is the most standardized indicator? And somebody questioned, I have just seen that if H index is suspicious, why much importance is given on it? Yes, importance on H index is given because calculation of H index is very simple. And yes, H index is suspicious, but H index is important. It it unveiled a new horizon. It opened a new arena, and H index alone developed so many other indicators. That's why we give importance on H index, or rather publication world today gives much importance to H index. Rather Google gives, rather not only publication world, Google, Elsevier, Springer, the entire publication world, they give much importance on H index. And that's why H index is so much. It is actually, but to my opinion, yes, H index is to some extent overhyped, and other indicators should be developed on the basis of H index. And adequate research should be done on this issue, that how indicators could be standardized. That's one approach. The ratio method I just presented, the ratio methods, and right now we are doing work on it. The by ratio method, we developed one Bell Hipsa indicator, and which eventually showed that Riemann zeta function, which explained the calculation of indicator in terms of Riemann zeta function, like zeta 1, 2, 3, etc. And that is the point. So Riemann, that is the point. So this type of Riemann zeta is one type of standardization. So these types of other modes of standardizations are required. And there is scope of adequate research in this area, standardization of indicator. So this is the scientometrics is still unexplored area. Much papers are published on this area, but little research is done. Little
Yeah,
research
I
is being
completely agree with you, Bidartida. In fact, the component which you said about standardization, I remember during my small tenure at Germany when I
Hmm.
made Eugene Garfield, and
Yeah.
he was 93 years old at that time. So Eugene also said the same thing, that we have so
Yeah.
much of impact factors, and everywhere we are calculating of the scientometrics. What is the standardization was one component, and the validity of one particular factor with over the others. So that's the thing.
Yes.
So because it is a
Definitely.
subject to subject, it depends. Number one, you have already shown
Mm,
your presentations, and
mm.
currently when we are looking at the interdisciplinary research where the mixing of two subjects is taking place, which impact factor
Yes.
should
Mm,
should be taken for consideration.
mm.
So I remember that this is the same thing and all. Thank you, Bidatida. It was a
Yeah, yeah. Thank you,
phenomenal
Shantanu.
it was a phenomenal presentations. Listening to you is always, remembering those days, I think. And thanks to for taking the name of Professor BK Shen. Shenda was my very close, very,
Yes,
very close.
yes.
In fact,
My
he's
teacher. Mm,
yeah, so and during Innsdock and all, and in fact, he used to stay near to my residence, and during his
mm.
last breath also I met him, Professor Bikeshen and
Ah,
all.
in Sierra
Yeah,
Park.
so we really missed a big person in the profession.
Mm, yeah,
Actually,
yeah.
we really
Yes.
mixed a big person. You thanks
Yeah.
for remembering. Yeah, Udan.
So we have one last question. What is supposed
Yeah.
to be a standard impact factor of a journal?
Yes, standard impact factor means impact factor is there, but impact factor it approximates in a bad way. It is an approximation, but it approximates in a bad way. And when you have no other weapon in your hand, you have to see it, and you can get just a rough estimation from the impact factor about the quality, but you will not get a very accurate picture. That is to say, yes, do not throw away impact factor, but also do not rely on impact factor blindly. Do not 100% rely on impact factor. That is the point.
Thank you so much, sir. Now it is
Thank you.
my pleasure to invite Dr. Santanu Ganguly, sir, to deliver today's keynote session. Over to you, sir.
Thank you, Udayan. Thank you, Vidyarthida. Thank you very much. Is
Thank
listening to
you.
you. I don't know how much I would be able to do a justification in my presentation because you have covered, in fact, everything. So, but still, it's my responsibility to say few. So, my dear participants, so you have already listened to the person who is an authority in this area. So, I will not
No,
be
not
speaking.
authority.
Yeah, yeah. But Vidyarthida is known for scientometrics and all, I remember. So my session is going to be, just let me know if all of you can see my screen. Is it
Yes, sir.
visible?
Yes, sir. Yes, sir.
Okay. So once again, welcome to the ecosystem of interdisciplinary research at Ashoka University, Sonipat. In every session, I generally give this particular presentations because it's my university where a lot of interdisciplinary research is given a lot of importance to this particular area where we deeply looking into. In fact, we are started calling it as a research university, not a very a simple university, but a research university where research is given a tremendous amount of importance in today's context. I don't want to take much about because already Bidathida has taken a lot of things, but I'll certainly look into some of the major aspects of multidimensional research metrics from an impact to the altometric analysis, where we'll look into the traditional citation-based methods to dynamic real-time altometric indicators and all. And thanks to Bidathida, when he was I was completely taken aback when he was showing the classical example of the E is equal to mc square of Albert Einstein vis-a-vis the theory, the formula given by Paul Dirac as well as by the Max Planck. So I was looking at the Veblen theory and all those. So thank you for those are all traditional metrics and all. So which is a very important thing. Now the foundation is a very important thing. The traditional metrics. It is a citation, journal rankings, dominated the entire scholarly evaluations. And in fact, there is a lot of academic impact as a measurement takes place with the methods of the traditional metrics and all. Now, the pillars of the scholarly impact citation is they said already he said that there is something called a citation counts. There is H index, there is journal impact factor, that is JIF, which is we take from the Web of Science, which gives the complete valuation of that. But the limitation of the traditional metrics is that there is a time lag. Citations accrue slowly. Groundbreaking work may take years to be recognized in the citation counts. In fact, in the examples, when you see, when initial stage, when Albert Einstein's theory was there in the paper was released in the journal, not many takers were there. In the same way, the Professor S.N. Bose, the famous bosons theory, when came out, of the how the quantum mechanics is looking into the condensate part of it. So not many people were takers, but slowly when they came, when his name was joined with Einstein, then suddenly, there was a lot of research. People started getting into his papers, started looking into, researchers started working in his papers and all, and the citations went up of the bosons theory in a many-fold. So that was a thing which came out, and thanks Vidyarthida for bringing out those things. I mean, I go back to my physics days actually. So there is a narrow scope, so focuses almost exclusively on academic citations, missing the broader societal engagement and the public discourse. Disciplinary biasness is there, is differed very dramatically. A humanities paper rarely accumulates citations at the rate of a biomedical one. You have already shown the example. And the gaming risks like citation manipulation, self citation rings, the journal coercive practices can really distort the integrity of these scores. Past citation centric evaluation is, for decades, the academic world relied on a narrow lens, citations and journal prestige, to define the world of scholarly work. This approach, while foundational, captured only a fraction of true research influences which has taken place actually. But it was a dawn of Altmetrics which started coming in. As research moved online, scholarly conversations were taken up, shifted to a social platforms, a new family of metrics emerged, capturing the attention, engagement, and reach in real time and all. What exactly the Altmetrics? So I'll be covering the mostly the Altmetrics part. A new lens for research impact, Altometrics, alternative. It is basically called as alternative metrics, but generally we combine the both word and we call it as a Altometrics. It captures online attention, engagement with research outputs. Unlike citations, they are available in their real time and reflect a nuclear broader audiences. Now, when we are talking about engagements, there was in traditional metrics, it was engaged in the all the like-minded people, all the scientists were engaged on, or all the researchers who are engaged on that particular domain. It was domain specific. But today, with the altermetrics or alternative metrics, it is not like that. It is cross-disciplinary, number one. Number two is that there is an engagement from the academics, there is an engagement from the policymakers, from the journalists, practitioners, and the general public, painting a richer picture of how research travels through the society. So basically, when you create a research on a particular area, so one thing is that you have an output. So your article gets published into some impact factor journal and all, and you get a prestige for that. So that's an output. And your paper gets cited several times and all. That's output. But most important thing is that outcome. Outcome is a very important thing. When you have done a research, how much impact it has created in the society, what level of impact was created in the society, is what is what people are in current context is looked into. In fact, when you talk about the altometrics, there are large number of uh, grants which get funded on these areas. Specifically, they look into, there is a measuring index also of the outcomes and not the outputs. So outcome is a very, very important. Let me give you a very simple example. When I was with All India Institute of Medical Science, AIMS, New Delhi, so every quarterly I used to bring out this, the research done by research published by my researchers. And there's a humongous amount of data used to come out every quarterly by the doctors who are on a different subject areas, thematic areas, and all they were bringing out. But one of the most important thing is that, say for example, there is one clinical trial is there, and that foolproof clinical trial had saved a disease, saved a patient from a disease. It's an outcome. So these are very, very important to measure as far as the society is concerned. And so in the Altmetrics, you have a diverse audiences. So it is not only the one audience, only the domain specific audience, but there are various people who are a part of it. There is a rise of online scholarly communication, which is in social media platforms like Twitter, LinkedIn, Facebook, and our primary channels for researchers to disseminate their findings and spark the public conversations. Blogs and news outlets like scientists, journalists, and bloggers routinely reference and amplify the research, bridging the gap between academic papers and public audiences. And then the reference managers like Tools, Mendeley, Zotero, and all, they are actively using the research in their own work in this context. Now, there is a digital ecosystem, and which is basically create an impact. Research how reverberates across a complex, interconnected web of platforms, each channel generating unique signals about how ideas are received and shared and acted upon and all. Ultimate sources indicators are social media platforms. So how many tweets are there, shares and there. In fact, in one of the when I was taking a session in one of the management schools, so they were asking me that how do I measure if as far as the Twitter is concerned, or maybe Facebook is concerned, how do I measure all this? So there is I have shown them a kind of a there is a KPI, which is a key performance indicators. There is an indicator levels are there by which if you put the values, it calculates and tells you that how what was the reach of a particular component or a message which you have shared in the social media platforms, how was the rate of that. So that was looked into. News and blogs coverage, policy documents, reference manager saves, and the downloads and the views which are always there. Now let us diving deeper on automatic analysis in practice. We need to understand the different tools with the scores, systems that make automatic analysis operational, from composite scores to domain specific frameworks. The automatic score, which is called AAS, is this social media mentions, the news coverage, the Wikipedia citations, the blog post, the reference manager saves, and the policy documents. It aggregates mentions across dozens of sources into a single weighted number and making it easy to compare the online reach of different research outputs at a glance. So each source type is weighted differently based on the perceived significance, provides a snapshot of immediate impact after publication, and then visualized via the iconic color-coded donut badge and all. Viral research impact in actions, which is social sharing search, like thousands of tweets and shares from marketers, academics, media personalities within the days of publications, news coverage explosions like featured in major tech and business outlets, and then high AS result like a top percentile automatic attention score demonstrating reach far beyond the journal citations would ever reflect. So there is a paper which was published by Wang Lu, Zhao, and Zi in 2024. It is called as SMI Altmetric, evaluating the Twitter X impact. So in that paper, what a comprehensive metrics he has developed specifically to quantify social media impact on the Twitter for scholarly publication. It was a beautiful paper I have gone through, built on 44,000 publications. Just remember, and 8,68,680 tweets on that. It incorporates literature related features, the engagement signals, the user authority, the content quality, and is achieved 0.867 accuracy using the XGBoost classification system. It is a very special classification system they have used, and if you go through the paper, you would be able to see that. One of the most methodically rigorous altometric framework they have developed on a social media evaluation till date, and nobody could compete on that. And this is a snapshot of that itself. Now, beyond the citation, there is something called a social echo. While journal citation can take years to materialize, A single viral tweet can bring a research paper to millions of eyes within hours, reaching audiences that no academic databases would ever capture. So there is another paper which very interesting. In fact, the paper was an eye opener for everyone of us. It is called Empire Index. This Empire Index is a value based framework which they have done exclusively on the social media platforms. And let me tell you that I call it as a extremely important thing. It was written by Paul Rees in 2022, and it was published in PLOS One. The Empire word stands for evaluating medical publications and integrating research evidence. And it was designed to provide a value based multidimensional framework or assessing the medical publications. The metric weighing informed like statistical analysis and stakeholders' input. It has big benchmarks against very high profile journal called New NEJM. NEJM publication is called New England Journal of Medicine, which is it is a society journal, a very highly ranked journal called NEJM. It integrates social, scholarly, and societal dimensions into a single framework. Let me tell you, friends, publishing an article in Nature and publishing an article in NEJM by a doctor, it is much more prestigious. You can imagine. So, this particular paper talks about one thing: social impact measured through automatic attention score, track engagement. How much people are getting engaged? Scholarly impact derived from the site score, which already Bidarthi has covered in his sessions. From site score, gauge the research influence within academia. And the third is unique insights into broader influence and the policy reach. Employee index components have, so there are three major pillars out of it. Strongly correlates with the Altmetric attention score, capturing how research resonates across digital and social channels. Its scholarly impact correlates with the site score, reflecting the traditional academic influence of a publication within the disciplinary community. And then the societal impact, the most distinctive dimension, providing unique insights into how research shapes policy, public health decisions, and community outcomes. There's one more interesting platform or a paper I came across. It was by Theng et al. In 2021. It is called ARIA. ARIA model is basically on Altmetric for research impact. It's for research impact, actually. So ARIA is a prototype system they have developed, built to address the critical gaps in existing Altmetric tools, particularly around the multidisciplinary analysis and the role-based metric interpretation. It supports cross-metric analysis across disciplinary boundaries. That is what we was discussing before starting this. When there is a cross-disciplinary boundary, how do we address that? When there is a subject metric, like for example, in Ashoka, we have an interdisciplinary research. How do you measure that in that case? What kind of framework should be followed? So ARIA looked into that kind of a thing. It implements an interactive visualization metrics and their sources, and the role-based views for researchers, administrators, and especially from the funding organizations, and bridges the gap between the raw Altmetric data and vis-a-vis the actionable insights which is coming out from the Altmetric data. So they look into that particular components into that. So it's a very important area. Mapping the research ecosystem. So Altmetrics like ARIA reveal the hidden architecture of research influence, showing now not just how much attention a paper receives, from whom it receives, from whom, from where, and in what context. That is what is the tool ARIA looks into. So please remember, as I said, please go through these platforms, Altmetrics for research, impact, actuation. These are very important areas which they have developed. Now, integrating the metrics, the multidimensional error. So I've been talking. So these are neither traditional metrics nor metrics, Altmetrics alone can tell you the full story. This which will includes into creates a more complete, honest picture of the research impact actually. As Bidati also mentioned that see, we need to have a hybrid model. So we have a traditional metrics where a deep validated citation records with longitudinal credibility and disciplinarity benchmarking are there. Altmetrics is real-time broad ease reach signals, capturing public engagement, media coverage, and policy relevance. And when I'm bringing these two together in a scholarly output, the hybrid approach comes into the picture. It's a holistic, inclusive measure of research influence, combining both depth of academic impact with the breadth of societal engagements. So a hybrid model is a very important, and that's I completely agree with what Vidyarthi mentioned that we should have a standardization of the platform. Dimension Analytics is a comprehensive database. I'm sure many of you must be knowing. One platform and multiple impact dimensions. Dimension analysis is one of the most comprehensive research database, integrating bibliometric data with real-world research outputs. Over 1.3 billion citations linked to public records. Altmetric data embedded alongside the scholarly metrics. It can track the grants, the data sets, the clinical trials, and the patents. And it enables a cross-dimensional analysis of the full research life cycle. In fact, I conduct a lot of training programs I've been conducting actually a lot of training programs on the dimensions analytics models actually. In dimensions are relative citation ratio. Citation based normalized to that's National Institute of Health funded publications, NIH funded publications. NIH, it's a very big umbrella of National Library of Medicine, Bethesda, USA. Benchmarks impacts relative to other research in the same area and time period. In fact, I had an opportunity. I'm the first student of NIH to uh, take the training on the Medlar's database at that time. It was called Medical Literature Retrieval Service, Medlar's database. And I have not joined at that time in AIMS New Delhi, but I got trained onto that by the NIH people to have this citation problem, look into these kinds of publication databases and all. At that particular, I'm talking somewhere around 90s actually. Field citation ratio, that is a normalized to specific fields of research like FOR, enables fair cross-disciplinary comparisons by accounting for different citation cultures. And altometric attention score like aggregated online attention from social media, news, blogs, and policy, providing the real-time complement to citation-based metrics. This is an integrated dashboard, a unified view. The modern research intelligence system platforms brings together a citation data, altometrics, grant information, and societal indicators into a single interface, empowering smarter, more nuanced and evaluation decision systems. In fact, very recently, one of my friend, he has developed it. By Udayan knows him, that Dr. Gupta, he is a pediatrician who has developed a very unique research intelligence management system. Probably I will request him someday to take a session with us to showcase that how these things, these intelligence systems are getting connected with the help of all this data which you come across. And there are some more things like how does it, when we look at the impact, how does it more look at towards the sustainable development goals, the 17 sustainable development goals given by the UNESCO and all. So that was one of the very important thing which we supposed to have it actually. So So, weighted and inverse altometric impact, that is called weighted altometric impact, is called principal component analysis. There are two sophisticated composite indicators that go beyond simple aggregation, and there is something called as inverse altometrics, which calculates by TF oblique IDF logic, like reverse the metrics that rear across the data sets and all. And highlighting distinctive signals over common noise, and all those things are basically a part of it, basically looked into. So, changes and directions. Ultrametric holds enormous promise, but also introduce new complexities around quality, standardization, and meaningful interpretation that the field is still working to resolve. Uh, n- uh, Working to resolve, and just give me 1 minute, please. So, so changes in automatic is standardization, which he has already talked about. There is an data quality and biasness. There is interpretation. There's a disciplinary differences are there on the clinical study, the physical papers and all, and the same thresholds has got a very big problems nowadays. Navigating the nuances, what does it all mean? Like field's greatest challenge is developing interpretive framework.
So sorry for
Translate.
interrupt. We have to quickly wrap up. Time is our limited now.
Okay, fine. So, what I would think there is a just I will take one case study. Give me 1 minute for taking a case study. This is a Altmetrics in action with case study. This is a case study on a breakthrough in medical discovery, a new treatment of a rare disease published in some of the clinical journal, and where the traditional metrics, moderate citations with niche medical journals would appear unremarkably evaluations. So Altmetrics helps to patient advocacy blogs, major health news outlets, and insights, and lab to life real world resonance took place. So when patient caregivers, health advocates engage with the research online, that signals matters a lot. Altometrics makes the invisible visible, translating the human impact into measurable data points also. Basically, it is basically creating and connecting lot of things on this area. In fact, when I was going through an enormous amount of papers from the PubMed as well as from the Elsevier Health Sciences, I found that there are a lot of clinical case studies where the Altometrics clinical outcomes have given a lot of solutions to the people, society at large. So there's a lot of this is a case study on environmental study. It's a very on microplastics and the marine life. It's a classical case study I came across where standing sounding the alarm, the public awareness was amplified, and because of the so much of plastics were drowned inside the water and polluted it with the plastic packets, the bottles, and everything. So it was a one of the ultrametrics which given an impact and a voice to the society after going through the alarming things into that. There are a lot of applications are there. So I'll just quickly. There's a lot of aspects I would have taken, but yes. So my session is this present could be available to everybody. The is integrated and the future is multidimensional. This is please I want to tell you and thank you very much. And I really I mean I want to thank. I have taken the lot of research help from many of my friends and all who has helped me. So research impact, it needs to be measured, understood, and amplified. So thank you very much for your patient listening. I'm sorry there was a less time. So probably some other time I would be talking more on this area. Thank you very much. Thank you, Udayan. Thank you, Vidartida, everybody. Thank you. Over to you, Udayan.
Okay, sir, we have the two questions. For one question for Dr. Vidyarthi, sir. So, is there
Yeah.
any impact matrix that has been developed based on the real world impact of research?
Not yet, but there are researches on the way. And there are a couple of things I have seen which are case to case basis. They have developed it. In fact, I'm trying to look at on that particular area. That is my new area of research, actually, Vidyarthida, to find out a comprehensive research impact analytics model, actually.
Okay.
Yes.
Okay. And one more very interesting question: how to make user engaging PPTs as you are generating, sir? Kindly explain and tip and tools. Yes.
It takes a hell lot of time for me to uh, develop a PPT like this. But only thing is that uh, most important thing is that I have a lot of materials before preparing any PPT, and because a lot of case studies and all, I have to pick it up, and then I put together them in a very logical way, and then it gets presented and all.
Thank you, sir. Thank you.
Thank you,
So,
Shantanu. Very, very nice presentation. Thank you. I have learned a
Thank you,
lot from
thank you, thank you, Vidyarthida. Thank you, thank you.
you. Yes.
So, as we conclude today's session, we reflect on how relevant this topic in this today's era of data-driven research, ranking, and global visibility and responsible assessment. Research metrics are no longer limited to the impact factor alone. Today's institutions and scholars must understand a broader ecosystem, including citation, collaboration, and impact. This session help us understand how to navigate that changing landscape with clarity and responsibility. As we come to the end of today's session, I would like to express our sincere gratitude to everyone who joined us and made this webinar meaningful through your presence and participation. A heartfelt thanks to Dr. Vidyarthi Datta sir for sharing such a valuable insight on research metrics, citation indicators, and all metrics. I would also like to extend my sincere thanks to Dr. Santanu Ganguly sir for this constant encouragement and visionary guidance and support this making this webinar series a success. A special thanks to all the participants for your active presence and engagement throughout the session. On behalf of HDFC Library Ashoka University, thanks once again for joining us today's session. On behalf this library, HDFC Library, I also wish everyone happy World Book Day and Copyright Day. Thank you, everyone. See you tomorrow.
Udayan, thank you very much. Thank you.